Because ZOS map all plain pages and slot into addresses, it is important to have an address space which includes system code and data as well as user's code. The instructions are all mapped in addresses available for user's code and data. This address space may refers to the range of either physical or virtual addresses accessible to the processor or reserved for a process. Uh, ZOS provide each user with unique addresses space and maintain the distinction between the program and the data belonging to each address space. Each address space is isolated from one another so that if failure occurs in one address space, it doesn't affect another address space. To better understand this address space, we have here uh, at the top we have a register. We have the access registers, general registers, and the floating registers. We also have control register here in the left. Uh, Access register specify the address space in which data is found, while the general registers uh, address data in storage and also hold users data. For the floating floating point register, it's hold the numeric data, and control register used by operating system is set to have reference to the translation table that we discussed earlier. And then in COS, dispatchable unit of work are represented by the control block. This control block represent task executing within the address space, such as users program and system program that support the user's instruction. A control block contains information about the running task and such as the address of any stored storage area that created. And then control block are created in response to the attached macro, yeah, by issuing the attached macro coming from the processors. Users program or system routine begin the execution of program specified on the attached macro, and as a subtask, the specified program can be complete to the processor time and can use certain resources already allocated to the uh, uh, auxiliary storage. And one of the another key component of ZOS is what we call the swapping. Uh, ZOS uses this to balance the system workload and ensure that adequate supply of available real storage space is maintained. And and then also in ZOS, the dispatcher component is the one that is responsible for routing uh, control to the highest priority of unit of work. that is ready for execution. No? It is already found in the address space. Uh, in this slide, we have a table of job wherein it's labeled and ready in the central storage, central storage and waiting for the dispatch. And then we have in wait in central storage but waiting for some event to complete, and the out ready to execute but swipe out, and uh, or out wait meaning swap out and waiting for some event to complete. We talking about here for the job, no? And on only in ready work can be selected for dispatching. When the entire application is moved from real storage to auxiliary storage, meaning it is swap out, no? The we called earlier the swapping. No? This means that all the pages, including the working set, are moved to a separate swap data, and then the real storage now uh, pre-up. And basically, those are the important key features of the Z operating system. Uh, we discussed these primary key component, the modules or the what we call the registry, the system macro, and some system component, the uh, the SW, and the multi-programming and multi-processing, and we also discussed the counter block and the different storage system that uses. And now we are ready to go to the important component of this Z operating system.